Just make sure I'm in the frame. We can be running all around the room here today. All right, so the polar coordinate system. Polar coordinate system is in contrast to the thing which you already know, namely the XY, or the rectangular coordinate system. That's the XY thing with the XY grid. Today we're talking about something with a different type of grid. Different type of graphing going all the way back. The rectangular coordinate system is sometimes called the Cartesian coordinate system, or you plot it on a Cartesian plane, which comes from the name Rene, one E? I don't know how you spell close Rene. I know how to spell his last name, which is the most important part. Descartes, which looks like Descartes. But it's French, so you say it differently. Rene Descartes, super intelligent mathematician, basically came up with the XY grid, all right, as well as a whole bunch of other stuff. So, in the rectangular coordinate system, you had an ordered pair with the X in the first position and the Y in the second position. And the X told you how far left and right you were, and the Y told you how up or how down you were. And we had positive X, which meant to the right, and we had negative X, which meant to the left, and we had positive Y, which meant up, and we had negative Y values, which meant going down. And if you actually were to graph something on here, or you were to have Cartesian grid paper, you would have like vertical lines denoting x value of 1, x value of 2, x value of 3, x value of negative 1, negative 2, negative 3, as well as horizontal lines, and you ended up with this grid paper, which is all kind of a mess. But that's kind of what we know and what we're familiar with. The polar coordinate system also has an ordered pair, but in the first position we have R, and in the second position we have the theta. Sound familiar? In the rectangular coordinate system, we had the origin and these other things which are called the axes. This is the x-axis and the y-axis. In the polar coordinate system, we have the pole, which is actually like a dot. And we have the polar axis, which looks like a pole, but anyway, that's kind of weird. So there you go, the pole and the polar axis. In the polar coordinate system, the R tells you the magnitude of the distance that you are from the pole. Magnitude of the distance from the pole. And theta tells you the direction that you are as rotated from the polar axis. So we'll say the direction rot, which stands for rotated from the polar axis. Where if theta is positive, it's just what we've been dealing with all year long. A positive theta would mean rotation counterclockwise. A negative theta would be rotation. Did I say counter first time? Counterclockwise for positive theta. Clockwise. Allow me to superimpose an XY grid on top of this. Okay. Like we said, R is the distance, the magnitude distance from the pole. Positive R values. So positive R means along that theta. A negative R value, which we've never really had before. I've always told you that the magnitude always has to be positive, but with polar coordinates, you are allowed to have negative magnitude values. And what that means is 180 degrees or pi radians away, basically along that theta, but in the opposite direction. So we'll just say opposite direction. So I'll show you what that looks like in a second. I'm also going to give you some polar grid paper. Okay? And so because of that, it's going to have different values of r. So for instance, r values of 1, which would be a radius of 1, all the points that are distance 1, so it's going to look a circle. Or radius of 2, or radius of 3, or radius of 4. And then it's also going to have some lines showing you some different angles that are commonly used, namely our special angle friends here, like 45, 30, and 60. 45, 60, and 30 in each one of those quadrants. Okay? Let's get some graph paper into your hands and plot some points. Some polar points. Kind of looks like a spider web. Hand that to me. Has anybody done this on Alex? Mason has.
On the topic.
The topics, yeah. Not too bad, actually. Polar graph paper, here we go. Let's go ahead and start off real basic. I want you to plot the point three 30 degrees. Now you might need to have your tree chart out there on the side. The polar graph paper that I found online has the radians marked, but when they copied, they really kind of small. But 30 degrees, is pi over 6, which is that first little line right here. So, and we're going to count out 3 units, so 3 circles. So 1, 2, 3, and then up 30 degrees. There it is. That's the point. 330. What about the point 4, 90 degrees? Okay, so 1, 2, 3, 4, 90 degrees, right there.
Is that supposed to be like separate?
You can do the same one if you want. I just do it on separate. Right? What about 3, negative 30 degrees? Somebody want to tell me where that one might end up?
Yeah.
Say again?
Down.
Down, yeah. So 30 degrees, that's just our good old negative 30. So 1, 2, 3. Okay. Notice these are the terminal points on a vector with that magnitude and direction. Okay? So all of your vector knowledge is coming to the party here with us, and it's going to help us out. So, like if I said there's a vector with 330, then you would draw that, right? That's your vector. If I said a vector magnitude 4 and direction 90 degrees, then you would draw something like this. If I said a vector of magnitude 3, angle negative 30 degrees, then you would draw something like this. The only difference is for polar coordinates, we're just plotting the dot, which would be the end point of where the vector is. Okay? Any questions? I think we're gonna like polar coordinates. Yeah. Okay. Okay, let me test your knowledge here then. What about this one? Negative 3, 30 degrees. remember what I said, if that magnitude is negative, it's still a distance of 3 from the pole, but in the opposite direction. So here's what I would do. I would graph positive 3, 30 degrees, okay, temporarily. So 1, 2, 3, so I'll draw a little. But then let's go in the opposite direction. So that would still be along this line, but in the opposite direction. So it's going to be follow down here. So 1, 2, 3. That's our point. That's negative 3, 30 degrees. Okay. See if you can do this one as a table here. Negative 3, negative 30 degrees. While I take attendance. Alright, which quadrant do y'all think this is going to end up in? 2? 2? Well, let's see here. So, what I'm going to plot regular is positive 3, negative 30 degrees. So that's 1, 2, 3. Going to temporarily plot that guy. Hey. Stop blinking at us. Thank you. Alright. And then go along this same line, but go in the opposite direction. So 1, 2, 3. Okay, yeah, y'all are right. Second quadrant, right there. That's how we would plot that. So sort of intermediate step. Now, something that's different about polar coordinates than their rectangular friends is that polar coordinates go by a bunch of different names. Okay? Can anybody tell me another name, perhaps, for this polar coordinate point? Three, yeah, 150. Would y'all agree with that? Because it's a 30-degree reference angle here, and so it's sort of like we kind of went, you know, something like that. 150 degrees, so 180 minus 30 put us at 150. Absolutely. Also, what if I had 3 and I could go all the way around this way? Negative, right? So all the way here to the negative x-axis, that'd be negative 180. And then I would tack on another negative 30 onto that, right? So negative 210. 180 minus 30. Okay. Negative 210. So we've been dealing with this literally all school year long, and that is coterminal angles. Okay? And so that's something that's different about polar coordinates from rectangular coordinates, because in rectangular coordinates, if we have the point 4, 2, I mean that's it. That's its name, that's its place. It's a one-to-one mapping. With polar coordinates, not so much. I mean, we could even go all the way around the circle one time. You know what I mean? We could go, you know, add 2 pi, add 4 pi, add 6 pi. Really not ever interested in that. Because your homework is going to require you to go through this process here, let's develop a formula real quick that'll make it easy for us. Okay? So if I give you that original one, let's say I gave you the normal one, 3, 150. I'll put it right here. Alternate names for that, we said that one of them was -3, but then -30, because -3, okay, it was this guy. So -3, -30 degrees. Another one was, what if we went -3, can we go, what if we went all the way around right here? What's 150 plus 180 degrees, like normal way to go there? 330, right? So you could have -3, 330 degrees. That would temporarily put us right here, but with that negative, it's going to kick us off over to that. So -3, 300 degrees. So let's think about that. If I'm at 150, how do we get to the -30? -150 minus 180. Or to get to the 330, we just saw it, I added 180. So this would be 150 plus 180. Right? And then this -3 was just whatever the opposite was of that magnitude. So generically speaking, if I have r theta, I could convert that into -r, comma, theta minus 180, or I could convert it into -r, theta plus 180. Are y'all comfortable with that? And what if this was in radians? How would this formula be different? Nick? Yeah, plus pi and minus pi. So instead of 180, we do pi. This is definitely worth writing down. We're going to make use of that here momentarily. The other thing that we're going to do is convert between polar coordinates and rectangular coordinates. So let's say I had an r and a theta, magnitude and a direction. How could I convert that into an x and a y? Think x component, y component. Anybody want to make a guess for how we could calculate the x value given a magnitude and a direction? Good. I know it's been 4-day weekend. We got this. Let's go. For which sine magnitude theta? We normally would say magnitude sine theta. That is for, let's help them out here, x or y, for the y. So r sine theta. And what about for the x? Yeah, r cosine theta. Hooray! And what if we wanted to go the opposite direction? What if we wanted to go from rectangular to polar? So I give you the x and y, we want to find the r and theta. Somebody tell me, how can I find the r, the magnitude? Pythagorean theorem, that's right. R squared equals x squared plus y squared, or You can say r equals the square root of x squared plus y squared. And theta is, let's hear it, class. Are y'all just tired? Don't want to say it?
I forgot.
Super shy? Don't remember?
Don't remember.
Inverse tangent y over x. There we go.
Yeah.
Let's go ahead and make it real official. We'll say the absolute value of the y over x, and that's going to be our theta ref. Okay? How are we going to find the actual theta? Use your head. That's right. So theta ref will give us this. Oh, you can use your head on that one. Okay? Okay. Hey, didn't I tell you if you knew how to go convert from magnitude theta and x and y that you'd be good to go? Helped us with vectors, helped us with parametric equations. It's going to help us with polar. It's going to help us next week when we deal with complex form of polar equations and polar coordinates. Okay? So when we learn about the Sissy form. Okay? So we've got all kinds of great stuff. If you know how to go back and forth on this. All right. Let's look at some problems together. See if you and your table mate can solve questions 1 and 2. I'll be walking around answering questions. Kills you and Robbie want to team up. That might be a powerful team alliance there. Make sure you check your work on the back. Well, this is regular 7 pi over 4, which goes 1 quadrant, 2 quadrants, 3 quadrants, and the guy in the middle here, right? So negative 7 pi over 4 would be 1 quadrant, 2 quadrants, 3 quadrants, and the guy in the middle over there. Yeah. Ooh, I see some good answers there. Let's go ahead. I'm going to go over the easy one here first. Negative 6 comma 5 pi over 6. It's kind of weird. You used to read left to right, but reality, we probably ought to go this one from right to left. Let's find the 5 pi over 6 line. Got it? And then normally if this was positive 6, that would be out here. 1, 2, 3, 4, 5, 6. But remember, negative magnitude means go along that in the opposite direction. So 1, 2, 3, 4, 5, 6. That's how we do that one. This got it. Sure. That's fine. Nia, you can go see Coach Kruger for a moment.
My what?
Probably.
Sorry,
That's-
anyway.
I know. Hannah, I want you to walk with me on this. This one's kind of weird.
Oh,
See,
yeah,
because
please
the
do.
angle is negative, right? So if it was just regular 7 pi over 4, we'd be golden because 7 pi over 4 is down here.
Yes.
As we go up 5, okay? But that's, notice here we're going like that. That's positive 7 pi over 4. Now positive 7 pi over 4 is 1 full quadrant, 2 full quadrants, 3 full quadrants, plus halfway in the middle on the next guy, okay?
So you have to do it the other way.
I gotta go the other way. So I've gotta go 1 full quadrant, 2 full quadrants, 3 full quadrants, plus midway on that other guy.
Ah,
Make sense?
yeah.
And we're going to the 5th circle out, so 1, 2, 3, 4, 5. So the dot's gonna be right there. And
Yay.
that's why he is where he is.
Wait, what about the other one? Can you just say that?
This one right here, the negative 6, 5, 5, or 6.
Mm.
I would normally graph, I'd say, where's 5, 5, or 6? Well, positive 5, 5, or 6 is right here,
Yes.
okay? And with a magnitude of 6, I'd be sticking all the way out here. But this is negative 6, so I'm gonna go all the way, I'm gonna go along this line, but 6 in the other direction. So instead of going 6 out this way, I'm gonna go 6 that way, because the magnitude is negative. The recommendation is start with theta. Figure out your theta line, your angle line, and then deal with the radius. You wanna do another one? Sure. Let's do number 2. We'll do the first one first. Start with, she's starting with theta. So 7 pi over 6,
It's down here.
right down there, okay?
Yes.
So I'd be somewhere kind of along this line. Now, if this was a positive 5,
You can just stay there.
then I go 1, 2, 3, 4, 5. But since it's negative 5, I'm going to go in the opposite direction. 1, 2, 3, 4, 5. And that's that point right there. Alright? Now, always start with theta. Now this is negative 3 pi over 4. Now that's kind of annoying because if it was positive 3 pi over 4, I would know I could just go, to right there, which is 1 full quadrant, then the guy in the middle, the next one. So, but since it's negative 3 pi over 4, I'm going to go 1 full quadrant plus it's the guy in the middle right there. So I'm looking at this line right here, the 5 pi over 4. Make sense? And hey, my angle is positive, or my magnitude is positive, which means I'm just going to go from the pole out 1, 2, 3. Any questions? All right, let's look at another problem here. Perhaps number 3. Suppose a point has polar coordinates negative 6, comma 5 pi over 6 with the angle measured in radians. Well, yeah, obviously it's 5 over 6. Find 2 additional polar representations of that point. So find other names of that same point. Write each coordinate in simplest form with the angle between negative 2 pi and positive 2 pi. Okay, well, this makes me think of our little formula that we wrote and that we kind of figured out earlier, which is if you give me an r and a theta, then I'm just going to take the opposite of it. So if this happens to be positive, I'm going to make it negative. If this is negative, I'm going to make it positive. And then either subtract pi or add pi, or in this case, since they want 2 angles, I'm going to do both to it. Okay? So what that means is that another name for negative 6 comma 5 pi over 6 is going to be negative 6 and 5 pi over 6, let's go plus first, plus pi.
What do you have 5 pi over? Oh, 6.
It's 5 pi over 6. Yeah, that's super bad.
What does it mean? Yeah.
5 over 6. There we go. Let's do a little simplification, shall we? No calculator required. So, negative 6, positive 6. The enemy of my enemy is my friend. You ever heard that one, John? The enemy of my enemy is my friend. That's why we were friends with Russia during World War II. Because they were enemies with Germany. So, but it's pretty much as soon as we finish with Germany, then we're like, yeah, all right, Russia, it's on again. All right. 5 pi over 6 plus pi. Now they're going to want an answer in terms of pi. Okay. And our calculator, if you type all that in, it's going to give you a decimal answer. But we don't need no stinking calculator. Okay? We can do fractions. May have been a little while. Alright? How do I add two things that one forms a fraction? Common denominator. Okay? So I'm going to have to modify this pi right here to have a common denominator. I want it to be over 6. So I'm going to multiply it by a 6 in the denominator. But if I do that, I'm changing the value. So I'm going to multiply it by 6 over 6. Now, Rosa, tell me, what is 6 over 6? 1. And what happens when you multiply anything by 1? It stays itself. It's going to look different, but it's still the same value. Okay? So we have 5 pi over 6 plus 6 pi over 6. All right? So that's going to be a grand total of how many pi's over 6? 5 pi over 6 plus 6 pi over 6. 11 pi over 6. If you really want to do a calculator, you could factor out the pi's and just do 5 over 6 plus 6. Math, enter. You get 11 over 6. And then multiply the pi back in there. But we don't need to do that. This is one answer right here. This is one option. 6 comma 11 pi over 6. The other option is subtracting. Exactly. So negative 6 comma 5 pi over 6 minus pi. So that's going to be 6 comma, same song, second verse. We need to combine these two terms. I shall multiply this by 6 over 6. So I have 5 pi minus 6 pi all over 6. Somebody help me, what's 5 pi minus 6 pi? Negative pi. 6 comma negative pi over 6, or negative 1 pi over 6. My final answer, this ordered pair right here, 6, 1 pi over 6, and this ordered pair right here, 6 comma negative pi over 6. Simply utilizing this formula. Do y'all understand why the 6 is positive? Do y'all think you can do some basic fraction math? I think you can too. Leave the pi there. I want to make sure that we do at least one of every problem. So that took care of 3, which also takes care of 4. Let's look at number 5. Find the polar coordinate of the point that has rectangular coordinates, negative 5 comma 5 root 3. So notice that resembles the rectangular to polar. I recommend, make sure you get it right every single time, just draw a simple picture. If you wanted to, since this is rectangular coordinates, you can almost think of this like as a vector with negative 5 for the x coordinate and 5 root 3, or sorry, for the x component, negative 5, 5 root 3 for the y component. Which quadrant are we going to be in, class? Second quadrant. Kick over negative 5. Kick up 5 root 3. We are looking for the r and the theta, but we've got theta ref right down there. So, Mia, how do we find the r? Yeah, she remembers Pythagorean theorem. So r squared equals negative 5 squared plus 5 root 3 squared. So r squared is 25 plus 5 root 3 times 5 root 3 is going to be 5 times 5, so that's 25. Root 3 times root 3 is 3. So 25 times 3 is 75. 75 plus 25 is 100. So we have r squared equals 100. R would equal plus or minus 10. You can say, which one is it, plus or minus? Well, that's kind of our choice. We could pick a positive r value, which would then mean our theta would be up here, or we could pick a negative r value, which would mean that it would, but then we would have to having the angle down here, which is super annoying. So let's just go ahead and go to positive 10. And then utilizing our formula for theta ref is inverse tangent of the y value, 5 root 3, over the x value, 5. We'll do absolute value of all that sucker, so all the negatives go away. 5's cancel. Should our calculator be in degree mode or radian mode for this problem? What gave it away? Degrees, yeah. So, we type in inverse tangent of just the square root of 3. And our theta ref is, class? 60 degrees. Now use your head. If this is 60 degrees, what is theta? You may want to... 120. Because we do 180 minus 60. Yeah, okay. So 120 degrees. Yeah. Jokes over there. So final answer. In ordered pair format, radius of 10, or magnitude of 10, whatever you want to call it, at an angle of 120 degrees. Feels kind of familiar, doesn't it? It should. We've literally been doing this like for the last 4 months, or 4 weeks. So, okay. Just instead of saying convert, find the magnitude and direction of this vector, Oh, AI plus BJ form. That was the other one, right? Same thing, okay? Y'all and your giggling are going to get in here in a second. All right. This one's to the nearest hundredth. We can handle that. It's just... Here we go. Number 9. Find the rectangular coordinates of the point that has polar coordinates 2, negative 3 pi over 4. Find the rectangular coordinates. Maybe we should draw a picture here so we know which quadrant we're in. Where is negative 3 pi over 4? Well, okay. I gotta look at my unit circle. She says third quadrant for negative 3 pi over 4. Yeah, that seems right, because positive 3 pi over 4 is, over here in second quadrant, that'd be positive 3 pi over 4. A whole quadrant and then half of a quadrant here, so therefore we've got negative 3 pi over 4. So we're down here, folks. That sounds good. This is, since this is polar coordinates, that means 2 is our r, and negative 3 pi over 4 is our theta. They want us to find the rectangular coordinates, which is just a fancy way of saying the x component, the y component, of the x and the y. So for that, we go to the formula. X equals r cosine theta. So 2 cosine negative 3 pi over 4. Now, if you look at the back, they don't specify it here in the directions, but they want exact answers, okay? So they're going to want stuff in terms of square roots and everything like that, okay? What is the regular positive angle that negative 3 pi over 4 corresponds to? 5 pi over 4? So going around this way, that's a good 5 pi over 4. I might want to write that down. Because we could just say, all right, let's find the cosine of 5 pi over 4, since it's the same exact location. How do we find the exact value of cosine 5 pi over 4? That's right. Go to your unit circle. Find 5 pi over 4, and look for the x value of that coordinate. Ashlyn, what is the x value? Negative root 2 over 2. So we have 2 times negative root 2 over 2. The 2's cancel, so we just have x equals negative root 2. Remember, don't make the classic mistake of replacing cosine of negative 3 pi over 4 or cosine 5 pi over 4 with the cosine of root 2 over 2. That's not, you're not converting this to that, you're converting that whole cosine expression into negative root 2 over 2. So there's our x value. Our y value, you utilize the formula r sine theta. So 2 times the sine of negative 3 pi over 4. Negative 3 pi over 4 doesn't show as is on your unit circle, but as I said a moment ago, 5 pi over 4 does. So 5 pi over 4. And so to the unit circle we go same reference angle, but now we're looking for the y coordinate, which is same thing, also negative root 2 over 2. So our y value is 2 times negative root 2 over 2. So y is negative root 2. We found the x, we found the y. Let's put it in a nice manner. That's not nice. Negative root 2, comma, negative root 2. Alright, class. So today, in reverse order, we talked about how to convert from polar coordinates to rectangular coordinates, how to convert from rectangular coordinates to polar coordinates. We talked about how to find different names for a given polar coordinate. We talked about how to graph polar coordinates with positive and negative magnitude and theta. We also talked about just what the heck the polar coordinate system is and how that relates to the Cartesian or the rectangular coordinate system. Okay? You have everything you need to solve this homework. Tomorrow we'll talk about polar equations. All right. Thanks for watching.